left and right tailed or sided test. Okay, what is there? So you saw the distribution, right? So the t-test statistic is like this. So what will be the, where I will measure, whether I am measuring on the left tail or the right tail, where I am going to measure the test statistic, or both the tails, two-sided test. Okay, so that's the question. My t observed can fall any side, right? It can be positive or negative, because generally this is the 0. So it can go anywhere. So in which case, which side of the tail I am looking, and depending upon that, we'll look on the table. The table we'll have, which will give me the values. So we should know what we are doing. And this, whether it's a one-sided test, two-sided test, left tail test, right tail test, this will come from our alternate hypothesis. And let's understand how. Okay. So first of all, let me write. So I'll cover all of them together. Concept is same. So all of this depends on our alternate hypothesis. So what is my alternate hypothesis? Because we'll not know, my null hypothesis is always same, that everything is same, nothing has changed, everything is equal. My null hypothesis remains the same across tests. So what is my alternate hypothesis? That they are not same. There is some change. Okay. So let's continue our medicine 2 sample test. So what was our so MM1 and MM2 mean recovery time, and what was the T observed? Mean recovery time of medicine 1 minus mean recovery time of medicine 2 by square root of standard deviation by N1 plus standard deviation square by N2. This was my T observed. Now look at this. So the denominator here will always be positive. Will always be positive, because this is a square here. S1 square, this is positive, and N1 and N2 are sample sizes, this will be positive, and this is a sum of 2 numbers, so this will always be positive. Okay, this will always be positive. Denominator is always positive. So the only thing, so if it is negative, right, say for example, this is 0. So my T observed here, value, what values will it take? It will depend on the numerator only. So if mean recovery time, MM1, is greater than MM2, then it will go on the positive side, because this one is greater. And if MM1 is less than MM2, then it will go on the negative side. Right? It will go on the negative side. So if we go on the positive side here, then this is called a right tail test. And if you go on the negative side, it is called a left tail test or left sided test. Okay, so let's go one by one. So case 1. We'll see. Case 1 is MM1 is greater than MM2. This is my alternate hypothesis. So I'll state the alternate hypothesis itself. So alternate hypothesis is that MM1 is greater than MM2. So if medicine 1 recovery time is greater than, so this term will be positive. So finally my T observed will be positive. This implies my T observed will be positive. Means, where will I have to look? Where will I have to look now? The distribution of the PDF. Here, T observed will come somewhere here, as we saw here in this case. So my T observed will be somewhere here. On the right side. Similarly, the other way around, case 2. If my alternate hypothesis is that the mean recovery time of medicine 1 is less than mean recovery time of medicine 2, then what will happen? Where will my T observed be? It will be negative now. If this is less, means this is less than this. So this whole numerator will become negative. So where will my T observed go? Towards the negative side. So my T observed will be somewhere here. Less than 0. So this will be a left-tailed test or a left-sided test. Okay, this will be a right-tailed. Right-tailed. This is because we have distribution as tails. Okay, and this will be a left-tailed. And now case 3 will be, say for example, my alternate hypothesis says that both are not equal. It just states that whatever is the case, they are not equal. I don't know whether it's less or more, but both are not equal. That's my claim. Okay. So what will happen here now? So I'll have some significance level here. So my t observed, so there will be some significance level, okay, alpha. So I'll just write here. So for example, this is my t alpha by 2, t alpha by 2. This is, for example, for the left side, I'll give another number. This is t1 and this is t2. Okay. So I'll divide my significance level. Say, for example, if my significance level alpha is equal to 5%, and assuming for this distribution, the curve is symmetric, which t distribution is. So I'll divide this into the two sides. So I'll make it alpha by 2, that is 2.5% on both the sides. So 2.5% here and 2.5% here. So area under the curve will be 2.5% and here it will be 2.5%. I will divide my significance level if the distribution is symmetric on the two sides equally, and now I will measure my t observed. So now t observed I'll get on both the sides, because it is not equal. I'll consider both the cases and I'll see where my t observed lies. If it is on the extreme right side, automatically it will be less than t alpha by 2, and if it is on the extreme left side, it will be automatically less than t alpha by 2 on the negative side, t1 alpha by 2, t2 alpha by 2, and then I can accept or reject. If it is more, then it will come here, it will come here, then I can accept it. But both the sides, I will get. If I'm getting only one value, depending upon what values I'm getting, if I'm getting only one value, then I can check whichever side it is. If it is less or more, if it is going on the extreme left or extreme right, either of the side, it is extreme, then I can reject it. Or if I'm getting here, then I can accept it. I hope this is clear. This is your two-tailed or two-sided. Okay, this will be your two-tailed or two-sided when there is inequality. Inequality means just not equal to. This is also inequality. When you have less than or greater than, then that will be single-tailed, one-tailed, one-sided, left or right. But if there is not equal to, then this will be a two-tailed or two-sided, where it can go on both the sides, and if the test is symmetrical, I'll divide the significance level into half on both the sides and I'll measure where my t observed lies. For example, if my t observed is here, either here or here, then I'll reject it, because the area under the curve, this p value will be the area under the curve under this, and this will be less than my significance level, and then I'll reject my null hypothesis and accept the alternate hypothesis. I hope this is also clear.